So let's compare a NSX Fabric with an ACI Fabric and check the logical constraint on both the fabrics, right? So in the NSX Fabric, you have different components. One of the main components of NSX Fabric is NSX Manager, uh, which will be associated with the vCenter, right? So NSX Manager has different roles, right? So one of the role is it act as a control plane and as a management plane. So it do participate in the control plane. So NSX Manager has two functionality. It will have control plane and management management plane. But when you take Epic in an ACI Fabric, Epic does only policy management, right? So Epic is a policy station which pushes the policies towards the ACI Fabric, right? So Epic is a management station and does not participate in the control plane. So if you want to build an ACI Fabric, the first thing that you will do will be connecting the Epic towards the leaf, right? So when you connect an Epic to the leaf, it uses LLDP and discovers the leaves in the ACI controller, which is Epic, and then you go and register the leaf in the ACI Epic by giving some information, right, like the node ID and all. So the first thing is you discover this leaf, and this leaf will use LLDP and find out the spine, and the spine will get registered in the Epic. You do the same thing, give a node ID and track or other details. Then you will find out the other leaf associated with this spine, right, and you will register everything in the Epic. So that's how an ACI Fabric discovery is done. And in ACI Fabric, there are different type of leaf that you call as a naming conversion, right? Mostly as a best practice. So you have something known as server leaf, and you have something known as border leaf, right? For this example, we take these two only. Now, border leaf is where you connect your external network, and all the traffic coming to the ACI Fabric and leaving the ACI Fabric has to pass the border leaf, right? Because your external router or external network will be connected towards the border leaf. Server leaf is where you basically connect your servers. Now, if you compare this with NSX Manager or NSX Fabric, you basically do a first configuration as associating the NSX Manager with the vCenter, right? So you associate the NSX Manager as a part of vCenter. The moment you do that, you will see all the EXSI host getting discovered in the NSX Manager, right? So you will basically have two type of nodes, a node cluster, right? So you will have a compute cluster and you will have a edge or management cluster. So once you see this host in the NSX Manager, you will make this part of the NSX Fabric, right? For that, you just configure the NSX by selecting the node. So you have two options there. You can either do it by using NVDS, that is a new distributed switch that is pushed, or you can use the converge VDS, right? So which means you use the existing VDS and make it part of the NSX Manager, right? So that's how you basically add the nodes to the NSX Fabric. The host that is added to the NSX Fabric is known as transport nodes. So you have transport node. Here you have transport node 1, and you have transport node 2, right? So these nodes are part of NSX Fabric and they will be called as transport node. You will also have edge transport node. You will not create a NVDS or the converged distributed switch in a management cluster, instead you just spin up the new edge cluster, edge appliance, the which has an NVDS inbuilt, right? So that's how the edge is created in the NSX Fabric, right? So you have transport node, which is equivalent to your server leaf, and you have edge cluster, which is equivalent to your border leaf. So edge cluster will be the entry and exit point for all the traffic to the NSX manager. Now, in an ACI, you have logical constraint, right? So you have something known as tenant. The tenant will be mapped or will be associated with different VRF, and VRF will be associated with BDs, right? So BDs is where you basically assign your IP address, and you have EPGs associated to BD, where you basically give the VLAN information, right? The encapsulation. And you compare this with a NSX Fabric, you have something known as transport zone, right? So transport zone is kind of equivalent to your VRF. So basically transport zone will identify the XSI host where the segments that you're going to create will reside, right? So transport zone basically is associated with segments. So segments is equivalent to a BD, and segments will be having port group, right? And port group will be equivalent to your EPG. So now let's say that your EXSI host, you're going to attach it to the NSX manager. During that time, you will basically add the transport zones as a part of the configuration that you're doing to add the EXSI host to the NSX manager, right? So if you take an example of, let's say, let's look at an ACI example, then we will compare it with NSX, right? So let's say that you want to connect a server with S1 to the leaf 1, right? So the first thing that you do is basically connect it, then make it part of an EPG. This EPG will be basically a part of BD, and the BD will be part of a VRF, or associated with the VRF. The VRF will be associated with the tenant. That's how the ACI Fabric works. You will have the IP address configured in the BD, right? And you will have VRF associated with the BD, and this VRF will be part of a tenant. When you compare it to the NSX Fabric and you want to connect a server 1 to the EXSI, what you do first is you connect it, like you create a VM and have a VNIC. So what happens means you will put this VNIC in the port group. This port group will be equivalent to an EPG, which will be associated with a segment where you assign the IP address, and the segment will be associated with the transport zone, right? So I can connect this server into any EXSI, or I can create this VM in any EXSI host where this transport zone is present, right? So if let's say that I want to add a new IP address, like for an example, I want to add a new server here with an IP of 11.0.0.1 and attached to here. So in if I am going to add a new segment, new VLAN, I have to go to the transport zone and create a segment with the new IP address, which is 11 dot, and attach it to the transport zone, right? So this transport zone will, if it's part of this EXI host, then I can create the VM here and the port group will be present. So that is so what whenever I associate a transport zone into a EXSI host, all the corresponding segments and the port group will be present there. So I just need to attach the VNIC to the port group. So if you compare the logical constraint, your tenant will be like your transport nodes, not just one node, all the nodes, right? And your VRF will be like your transport zone. So you can have different transport zone if you want logical separation. And your BD or L3 VLAN will be like your segments where you give the IP address, and your EPG will be like your port group, right? Which you basically give the encapsulation. Now, if you see the transport zone, there are basically two type of transport zone. One is known as overlay transport zone, and one is known as VLAN transport zone. So overlay transport zone is always used from an EXSI host to an EXSI host for the Geneve tunnel. So let's say that 10.002 want to communicate with 10.003, which is residing in another host, right? So the packet will hit here. If I am making it part of a transport zone overlay, it uses the Geneve tunnel and you know create an encapsulation and then it will be decapsulated here. But the transport zone for the VLAN, so there are two transport zone as I mentioned. One is for overlay and one is for VLAN. The VLAN is mainly used for one use case is for the edges, right? So edges have external connectivity towards the router. For example, for let's say this router. So what happen means edge will be basically connected towards your edge will be basically connected towards your router, that's your switch, and it can be extended to a router, right? So you need a normal VLAN here, for example VLAN 10, and you're not going to have any encapsulation for the Geneve tunnel here, right? It's just a normal VLAN encapsulation you have. So what you do means this port group will be part of the segment, and this segment will be part of transport zone VLAN, which means it will be basically having the normal VLAN encapsulation to take the packet towards the router where the next IP address will reside, and you can basically form a routing adjacency, right? So this is basically the main comparison between the logical constraints of an ACI network towards an NSX network.